To solve these mixed constraint problems, we can use a method called the Big M method. But in order to apply the Big M method, the problem must be written in what's called the modified form. So we have to get what's called the modified problem. Now, the steps to get to the modified problem are simply, first of all, if you have any problem constraints that have negative constants on the right side, you need to multiply both sides of your constraint by -1 to obtain a constraint that has a non-negative constant. And then after you do that, if you have any less than constraints, you just add a slack variable. Now if you have any greater than or equal to constraints, you introduce a surplus variable. You actually are going to be subtracting that because you're going to take away the surplus. See, remember earlier we talked about when a constraint was in the less than or equal to form, we would add a slack variable to balance it or make it equal. But to make it equal here, you have to take away a surplus variable. Now, what's kind of weird is anytime you add or introduce one of these surplus variables, you have to also add an artificial variable with that greater than constraint to convert it to an equation. And then on the equal to constraints, you have to introduce an artificial variable, and that's all you have to introduce there. Now, I think these artificial variables are really there just to make the number of variables and equations work out. So I haven't done a lot of research into that. Now, one last thing you do, for every artificial variable that's introduced, you have to add -m times each artificial variable to the objective function. And so remember, this m is just a big number, like, you can think of it as 1,000,000. So anyway, let's look at how to set up a modified problem. Alright, let's take a look at this problem. We want to maximize this objective function subject to these constraints. Now remember, the first step it says to do is you take each constraint that has a negative on the right hand side and you multiply it by -1 to convert it, to change the negative to positive. So this -x1 minus 3x2 plus 4x3 is less than or equal to -10. What we would do is we would multiply everything in this constraint by -1. And now notice what that's going to do. That's going to change the -x1 to a plus x1, the minus 3x2 to a plus 3x2, the 4x3 to a minus 4x3, and it'll flip the inequality from less than to greater than, and it'll change the -10 to positive 10. Now we also have to do the same thing down here where we have the -15. So we multiply this equation by -1 so that we get -3x1 plus x2 plus x3 equals positive 15. Okay, so now we don't have any negatives on the right hand side, so now we can proceed with the modified problem. Now, in order to write the modified problem, you remember when you have a greater than constraint, you introduce a surplus variable. So we take away the surplus, but also we have, when we introduce a surplus variable, we also have to introduce an artificial variable. So we add an artificial variable. So for the first constraint, we take away the surplus and then add an artificial variable. Now the second constraint is also greater than or equal to, so we have to do it again with different variables. So we introduce a surplus variable and another artificial variable, and then of course that's what converts these two equations. Now on the less than constraint, all I have to introduce is the slack variable. So I'm going to introduce a slack variable here called S3, and that'll convert that to an equation. And then on the equal to constraint, you just introduce an artificial variable. Now remember what I said, for every artificial variable, notice we introduced 3 artificial variables here. So for each of these artificial variables that were introduced, I must introduce a negative m times each one of those artificial variables to the objective function. So I'm going to have to introduce a minus m times a1, a minus m times a2, and a minus m times a3. And by the way, all of these variables that we're introducing are non-negative. Okay, so this is your modified problem. Okay, now what can we do with that modified problem? Well, now we can actually take that modified problem and put it in a simplex Tableau. And we've got a lot of variables here, so let's put a column for each variable. We have an x1 variable, an x2 variable, an x3 variable, an s1 variable, an s2 variable, an s3 variable. We have an artificial variable 1, artificial variable 2, artificial variable 3, and of course we have p. Now, once it's in this modified problem form, since these are all equations, we can just put in the coefficients here. So the coefficient here would be well, let's just read across as I put in the values. 1x1 minus 2x2 plus 1x3 minus s1 plus 1a1 equals 5. Now let's read the second equation. 1x1 plus 3x2 minus 4x3 minus 1s2 plus 1a2 equals 10. Now read the third one. 2x1 plus 4x2 plus 5x3 plus 1s3 equals 20. And then the last one is minus 3x1 plus 1x2 plus 1x3 and plus a3 equals 15. Now remember, when you put the objective function into the modified or into the Tableau, you have to move all the terms to the other side of the equal sign. So all of these terms will change sign. So the 3x1 would be a minus 3x1, the minus 2x2 would become plus 2x2, the x3 would become minus 1x3. And then these three minus m values, when you move to the other side of the equal sign, they become positive. So all three of these would be positive m values, and then you would have your 1p and your 0. And that's how you write the simplex Tableau for that modified problem. Now once we get this simplex Tableau, you could solve the modified problem by the simplex method, but there's something very important that you must do before you start the simplex method. The first thing you must do on that Tableau is you must use row operations to eliminate the big m's in the bottom row. So in other words, you must eliminate all m's before proceeding to the simplex method. Okay, then after you eliminate those m's, then you can solve this using the simplex method. So let's take a look at the Tableau that we have. Notice here that I have this m on the bottom row. So to eliminate it, I can use the 1 here that's in row 1, and I can multiply everything in this row by negative m and then add it to row 5 to get rid of that m. Now that's tricky because we're not multiplying by a number now. Well, we are, but it's an unknown number. It's just negative m. So when you do that, negative m times 1 is negative m, and add it to minus 3, you get negative m minus 3. Negative m times negative 2 is positive 2m, and you add it to 2, you get 2m plus 2. Negative m times 1 minus 1 is just going to be negative m minus 1. And then negative m times negative 1 is going to be m, and you add it to 0, and you get m. And then you multiply this by negative m, you get 0, add it to 0, you get 0. Same thing here, you're going to get another 0. And then when you multiply this by negative m and add it to m, negative m plus m is going to give me 0 there. And then if you multiply this by this by negative m, you're going to get 0 plus m is m. Same thing here, 0 plus m is m. And then same thing here, 0 plus 1 is going to stay 1. And then you multiply this by negative m and you get negative 5m. Okay, so that eliminated the m under the A1. You've got to now eliminate the m that's under the A2. So basically you're going to eliminate every m that's under the artificial variable before we start the simplex method. So now you're going to multiply right here in row 2 by negative m, and add it to row 5 to eliminate that m. So if you multiply everything in that row by negative m, well, here you'll have negative m, and if you add it to negative m minus 3, you get negative 2m minus 3. If you multiply this by negative m, you get negative 3m, and if you add it to 2m plus 2, you'll get negative m plus 2. If you multiply this by negative m, you'll get 4m, and if you add it to negative m minus 4, you'll get 3m minus 1. And then, of course, the zeros stay 0, and you just get m. And if you multiply this by negative m, you get m, and add it to 0, you get, let's see, I think that should be, oh, here it is, you get m. And let's see, what else did we get? So actually, under the S2, I should have a positive m, because negative 1 times negative m is m, and add it to 0, you get a positive m. And anyway, continuing this, negative m times 0 plus 0 is 0. Negative m times 1 is negative m plus m gives me 0 under the A2 column. And then negative m times 0 plus m gives me m here. Negative m times 0 plus 1 is 1. And then negative m times 10 would be negative 10m. And you add that to this negative 5m, and you get negative 15m. And then finally, I still got to eliminate the m under the A3 column. So you do minus m times row 4 and add it to row 5. And hopefully you've got the hang of this now. So you multiply everything in row 4 by negative m, and you add it to all these values that we have in row 5, and you should get this row here. Now, in the next step, you would actually take this and solve it by the simplex method. And so let me just kind of give you an overview on how that works. So once you get to this point where you've eliminated all of the m's that are below the artificial variable columns, then you start doing the simplex method. So the simplex method, you have to think of, okay, remember I said think of m as a million. So a million minus 3, that would be a positive value. Minus 2 times a million plus 2, that would be a negative number. 2 times a million minus 1, that would be a positive number. And of course, these are just a million, so a million would be a million. So the only one of these that would actually be a negative number would be the minus 2m plus 2. So you would know you're going to pivot on that column because the minus 2m plus 2 is the most negative number. And then you have to determine your pivot row. You can't use the negative 2 because that's a negative number. You would divide 3 into 10 and get 3 1/3. You'd divide 4 into 20 and get 5. And you would divide 1 into 15 and get 15. So the smaller of these three quotients would be the 3 1/3 I got when I divided this. So that means that the 3 would be the pivot element. So then you would pivot on this by multiplying this row by 1/3, and then you would multiply, after you pivoted, then you would multiply that row by 2 and add it to this to cancel the negative 2. Then you'd multiply it by negative 4 and add to this to cancel the 4. And then you'd multiply it by this by negative 1, add it to this to cancel the 1. And then you would multiply it by the opposite of this, which would be 2m minus 2. So you'd multiply this row by 2m minus 2 and add it to row 5 to cancel the minus 2m plus 2. Now we're not going to do that because this problem would get kind of nasty to do by hands. And so there are computer programs that can be used to solve these types of problems. Now I am going to show you how to solve a smaller problem, but we'll do that in the next video.